All right, so in this section we're going to talk about what does it mean to be a perfect square trinomial. And again, a trinomial means it has, tri means three. So a trinomial has three terms. You can see on number one there's three terms, x squared, 6x, and 9. So we factor this the exact same way as we normally would. We're looking for numbers that multiply to 9 and add to 6. And the only numbers that do that, we have 1 times 9 or 3 times 3. The only ones that add to 6, okay, 1 plus 9 would be 10. That doesn't work. 3 plus 3 is 6. So you could write this as x plus 3 times x plus 3. But a little bit more compact way to write this, how do you say, what's a faster way of saying x plus 3 times x plus 3? You could say that as x plus 3, the whole thing squared, or to the second power. And one thing I want to point out, a lot of times people will be given this and they'll ask, somebody might ask them to multiply, and they'll say, well, that is going to be x squared, and then 3 squared would be 9, so the answer is x squared plus 9. And you can obviously see that that's wrong, because when we do multiply this out, we should wind up with 3 terms right there. So that's the same type of thing we've been doing. The only difference is there's a special name for it. It's called a perfect square. Okay, let's do this one. So we want numbers that multiply to 1 but add to 2, and the only numbers that do that are 1 plus 1 and 1 times 1. So there's number 2 right there. Okay, number 3 looks kind of imposing because this number here is obviously a huge number. You could use the swing method for this. You could take the 16 and swing it over like we've done several times. But in certain cases, it's useful to notice something about these numbers. You might notice something about 16, and you might notice something about 25. And what you might notice is 16 and 25 are both numbers that appear in this list of numbers that I'm writing right here. And of course, this list of numbers, those are the perfect squares. That's equal to 1 squared, that's 2 squared, that's 3 squared, and so on. Okay, so the important thing is you can use the swing method, but you might as well try this as well. You might as well ask yourself, well, how could I have got 16r squared? I could have done 4r times 4r. And how could I have gotten 25? I could have done 5 times 5. And then if that's positive, and yet I'm adding things, I'm multiplying two numbers that give me a positive, but they add to be a negative, the only kind of numbers that do that are two negatives. A negative times a negative is a positive, and a negative plus a negative would be a negative. Okay, so this is actually what it factors to. That's the exact same thing as you would get using the swing method, but I would recommend if you see numbers at the beginning and the end that are perfect squares, try it this way and see if you wind up with a perfect square. And obviously the more compact way of writing this would be 4r minus 5, the whole thing squared. So that's what it means to factor a perfect square.